Hello, everyone. Thank you for joining us for another live webinar session hosted by EE Tech and All About Circuits. My name is Dale Wilson. I'll be your moderator. Today's session is brought to you by MacroFab and is titled How to Optimize Your PCB Assembly Costs, Tips from Insiders. Let me tell you a little about our presenters. Misha Goldstein is the CEO at MacroFab. He leads their efforts to transform the $560 billion electronics manufacturing industry through innovation. Previously, he co-founded Alert Logic, which became one of the fastest growing companies in cybersecurity. Also joining us today is Chris Church, the founder and chief product officer at MacroFab. He founded MacroFab in 2013 and is passionate about reducing risk and improving the customer experience in electronics manufacturing. Following their presentation, we will have a live Q&A session with Misha and Chris. You can submit your questions at any time during the webinar using the Q&A section on the right-hand side of your screen. We will provide our attendees with a downloadable copy of the presentation near the end of today's session. This will be available in the Handouts tab. Also, keep an eye out for a poll question that will be popping up near the start of the presentation, as the MacroFab team would like to get some insights from you. Thank you so much for joining us, and with that, I'll hand it off to Misha and Chris for today's presentation.
Thanks, Dale. So, Misha, I think you're muted there.
Apologies for that. I'm live now.
Excellent. So quickly today, we're going to have a conversation about how we can better manage cost optimization, how we might ensure our better quality and minimize defects, how we can focus around on-time delivery, some ways you can think about selecting the right manufacturing partner, and the ways in which technology can be leveraged to improve your efficiency in the process. But if we're going to go ahead and dive in first, we're going to talk about cost optimization and a few strategies you can use there.
So, Chris, we structured this discussion as a series of topics, and I think the overriding objective was to help people understand better what the manufacturing process looks like, what leads to certain costs, what is the best way to get a cost for a PCB assembly. And when you think about it, do you think about it as a prototype or a production problem or somewhere in between? It really doesn't matter what stage of production you're in, the considerations are the same.
You know, Misha, that's a good question, because when I think about this, I think about the product life cycle, right? There really isn't a distinct prototype and production. And when we think about our cost objectives and quality objectives, we have to start from the very beginning of the product design. We have to design for the outcomes we're looking for. So earlier in the prototype stage, we really need to be setting ourselves up for success in production. So a lot of the things that will become challenges later, especially when we're trying to ramp up into volume, we need to start thinking about those early on and start addressing those. I think obviously one of the things we call out here is lead times and availability. So just think about from our bill of materials perspective, if we are doing this from the early design stage and not waiting for production, what are the traps we get into as designers is really optimizing around best functionality, easiest to get, and not really thinking of or easiest to use for our components, and not really around whether or not our procurement, our contract manufacturers, et cetera, are going to be able to get those. So,
but Chris, when you say that, when you're in an EDA tool, you are choosing components for functionality first and foremost. You know about this more than I do, but I don't think EDA tools necessarily give you an indication of whether there is an out-of-stock component, long lead time parts. Is that easy enough information to get at a design stage?
Not all EDA tools do. Some are starting to build that in. I know Altium has recently added that functionality to their EDA tool. For obvious reasons, they own some of the software tools in that space. But there are other tools. You don't necessarily have to rely entirely on your EDA. There are third-party tools. There are platforms like MacroFab that can give that to you very quickly in the design stage. But I think it is incumbent on the engineers to consider that, even if their EDA doesn't do it, to, even if they have to go to their prototype manufacturer and say, hey, can you tell me about the lead times and availability? Because if I am designing in a component that is not readily available, that has a long lead time, I do need to be working with the manufacturer of that component, expressing my desire to use that, what my expected utilization is, so I can get on their production schedule, right? That is, to wait until you need a lot of the product to go back and talk to that manufacturer and say, hey, I'm going to need 100,000 of these this year. And they're like, we've already done this year's production and we only produced 20,000. That's too late in the game, right?
So in your mind, the workflow should be not exclusive to functional design, not exclusive to EDA tool only. When you have your own workflow as an engineer, you use tools to help you understand the sourcing picture side by side as you make design decisions?
I do, when I'm designing something. I don't know that all engineers do, but I think that is critical as a design engineer. And a lot of companies, they don't reward their design engineers for this, right? So we have to think about that at the company level and make sure we're giving the design engineers that opportunity. But understanding how the components you're choosing are produced, their relative availability, and helping your procurement team or your contract manufacturer to have insights on what you're intending to use is very critical in ensuring that you're going to be able to produce that when you need to produce it and not have to pay too much. Because I think, again, you go out there and you say, hey, I want 30,000 units of this. There's only 5,000 units on the market. Where are you going to end up? You're going to end up in secondary. You're going to end up in brokerage, things like that. And your procurement team is going to end up paying a lot more for that product than they should have to.
Yeah, that makes sense. So if you do take those things into account and you as an engineer make the right decisions and trade-offs on which components are used, what's the next step? I mean, ultimately, I think in this discussion, it's all about lowering the cost, right? So it's all about making sure that there are not cost overruns. So what's the next logical step in your mind?
Yeah, so if we're still at the engineering level here, the area I want to think of, we call out here, we talk about standardization, but where I want to think of is how, what is your level of visibility across all of the products you make? Is your company using a PLM or product lifecycle management system? Are you centralizing your part definitions? So this is a fairly common thing. You'll find similar parts used across the entire product portfolio. But if your engineers are working in a silo, they may not realize that you're already consuming a lot of a particular component that is will be perfectly fine for the design. And being aware of that, being able to go out there and say, okay, for a lot of our standard functions that we're going to use in a printed circuit board, we have part numbers defined for those in our PLM with our AMLs, et cetera, or approved manufacturer list set up in there, so that those engineers have a data set they can pull from, and they're not having to each independently do that. That will then allow you to create, once you get into that production stage, commonality across your products where available, and give you more bulk purchasing leverage. I've seen this, where a procurement person will come to me from a company with 4 or 5 different products, and the BOMs across all 5 of those products are incredibly distinct. And you look at it and you go, guys, if we were to adjust the AVLs or the AMLs for these products, we can create a lot of commonality. We can quote all this together, and we can save you 15, 20%. But if we quote these as spec, you're going to be paying more for that. And the effective use of something like a PLM within the organization, a product lifecycle management system, will really help to make that visible to the design engineers.
Now, at this point, you and I are obviously involved in a manufacturing world. MacroFab is a electronics manufacturing platform, so we help a lot of people build um, um, uh, designs in very different volumes, all the way from single unit prototypes all the way to millions of units on the same platform. So we deal with a lot of factories out there. But at one point, you were not just an engineer, you were an engineer because you were in a startup, you built robotics products. You're also a business owner. So going beyond the engineering lens, is it purely about the cost of the prototype run that you run in early stages? Or did you, as a guy that actually had to make business decisions, also consider really the entirety of your product lifecycle? How long does it take for me to have run multiple prototypes, iterate through them, really get the product to market? Because what's in between those prototype runs is meetings with supply chain team, and a lot of meetings sometimes if you end up delivering a bomb that is unsourceable. So did you think about it purely from the perspective of how long it takes for you to get a design in hand, or really the life cycle of getting the product to market?
That's kind of a loaded question. Of course, as a business owner, we care about the full life cycle of getting the product to market, and sustainability, and the overall cost structure, right? So, it's really easy to get in a trap where you're like, I want the next thing I'm doing to be as cheap as possible, right? But if you look at this, and if you go out and you map out the life cycle of the product, so today product life cycles are getting shorter, especially in the consumer space. You may only have a year or two life cycle in some of those products, but if you're building something that has a 5, 8, 10-year life cycle, you need to be planning for the overall cost structure and change you're expecting across that life cycle. So things like the cost of an R&D prototype, I was never really that worried about, as long as I had visibility into how quickly I could understand what that would do to the overall cost cycle. So speed and prototyping was always more important to me than the cost of the prototypes themselves, because that increases that information cycle, right? This bill of materials is going to work. We understand very quickly what the product is going to be made out of, so we can start thinking about overall procurement and sourcing strategies. And in particular, this is where we often ran into challenges. Tooling wouldn't get started until after prototype completion. And I think that's a mistake, right? Because this is where we often get in a pretty big trap. We have a functioning prototype. We're ready to go to production, right? Let's build 100,000 of these. We have no tooling, right? We have no test fixturing. If we're using ICT, we don't have the fixtures for the ICT. We don't have the programming. If we are, doing more of a complex assembly, do we even understand the tools we need to help put that together successfully? So this for me, being able to not just have that supply chain information early on in the R&D cycle, but being able to start developing the tooling, getting that fixed cost understood earlier in the process, gave me a lot more information about how I should think about cost savings over time with that product.
And that's probably one of the biggest hidden costs, because you can always delay the tooling decision, and it can always be done at a manufacturing stage. I guarantee you there's a lot of service providers and contract manufacturers themselves that are more than willing to charge you a lot of money to build test fixtures as you go to production. That is what inflates a lot of costs for projects. In fact, the people that really know how to build those testing tools better than anybody else are the design engineers. In my mind, it should actually be part of the product design. I think it's incomplete without something that actually puts it on a production line in a plausibly deliverable form. So a lot of times I see people get really overly fixated on what it costs them to run some small volume prototypes, but really kind of miss the stage that goes up into, let's say, hundreds of units, sometimes thousands of units. That may still not be high volume, but it's impossible to do without proper fixtures or tools.
Yeah, I think when we're talking about cost, we're often thinking about the quoted cost, right? What is that manufacturer charging me to produce this? But we're not asking about yield in a lot of cases, right? We can have a great cost, but if our yield is very low, we're going to have to continue to produce more units to get to our demand levels, and we're still going to have to pay for those. Someone's going to have to pay for those, right? If you put all the yield issues purely on the factory, there's a good chance that they're not going to be that interested in taking it, right? They're going to want to be a partner with you in this. So, understanding how that tooling can affect the yield is really about managing the costs in the long term. Our goal is to get to a very high yield, not necessarily as quickly as possible, but as quickly as the project will allow us, right? If we don't have any test fixturing, if we don't have any tooling yet, early on, we're going to have a very low yield, right? And we're going to have to think about, what is the point in time at which what are the different gates we're going to get through that are going to enable us to start really increasing that yield and really reducing our fully loaded costs, not just the per unit cost that's coming off the line right now.
Makes sense. Chris, anything else to cover here? Should we go forward?
No, I think we should go ahead and move on to the next topic.
So I think a lot of what we should cover in the next discussion is what happens in order to remove most of the common problems, how to actually make sure to put a product in a line that's going to be successful, eliminating those hidden costs, right? A lot of pain is concentrated in the NPI process, and I see this firsthand. It's actually quite amazing. There are very mature organizations out there where when they go to production, they realize that NPI is going to be one of the most expensive stages in their process, and they do everything they can to optimize it. They give it enough time, and they actually give it enough physical presence to make sure to work out issues. I've also seen a lot of vendors try to say, look, we're smarter than everybody else. NPI is not going to have to affect us. We're just going to crunch through it. And I've never seen a situation where inadequate NPI time ever works. It becomes miserable for everybody involved. It becomes a fire drill. Production lines start, then stop, then start again. It's a very painful process, and ironically, the biggest cost overruns I think happen at that stage, and that is where people truly realize, I extrapolated the cost to produce this product from a very limited amount of information, purely components placed on PCBs, costed out, multiplied times number of units I need to deliver, but just completely missed the boat on what it takes to actually scale up production and turn it into a manufacturable product.
Yeah, and I think part of that comes from, right off the bat, people look at what you might call, NRE, non-recurring expenses, and the overall cost of NPI. A lot of times they'll look at that as part of the unit cost on the first run and say, hey, this is just too expensive, right? Let's just move very quickly through this. Don't put those costs in. Really, we should be looking at those as capital expenses that are being amortized over the life of the product. And, if you're building, if the life of your product is 10,000 units, right? Obviously, $100,000 in early stage costs are going to result in $10 per unit in amortized cost. So you're going to want to be much more structured, that limited in what you can do there. But a lot of times we're looking at products that are going, they have an 8-10 year life cycle, and we're talking potentially millions of units. And people are really getting concerned about adding 2 additional days or $10,000 additional dollars in the NPI cycle, and not realize that it's really costing them a lot more money for every unit produced thereout. In that NPI stage, we have to think about using that time effectively, right? It's not just how do we figure out how to set up the line and get it running, but that question is again, are we managing to yield? Are we managing to the full lifetime cost of this product? And do we have very clear gates? Because a lot of times we see this happening is by the time you get to the NPI function, you're already behind on your sales orders. You're selling a product as you're designing it, and customers really want it. So you want to move really, really, really fast. And we get, you'll hear 2 things, right? I want it cheap and I want it fast, right? Because I sold it at price X, and my sales order is already overdue. Well, can't really solve that in NPI, right? So it's still important to think about it as a product owner, as a business owner, to really think about the life of that product. And maybe on this first sales order that I'm trying to get through, I'm going to have a higher unit cost because I'm still going through NPI right now, but that's okay because I'm managing for the next 50 sales orders after that, and not to get hung up in that, because this is where we find that people often end up getting stuck. They still don't deliver the product 6 months late, right? Because they are trying to rush through that NPI process and they keep having issues on the line, right? We keep having 50% yield rates on a particular component, et cetera. All of that can be discovered in the NPI process, but it has to be a thoughtful, well executed process that matches to the particular product and its process for building it, right? Obviously, some simple PCBAs, it should be pretty fast. Complex box build with secondary assembly, multiple sub-assemblies in there, that's going to be a much more challenging product to get through NPI.
So a couple of observations, because we work with thousands of customers, literally, and hundreds of factories, right? So we have the benefit of seeing a lot of situations. One thing that always surprises me is that assumptions are very different at various scale of production. And what I mean by that is some of the most beautiful, automated, and impressive factories out there actually have the easiest NPI process. I was blown away. I was in China visiting one of the factories, and I asked them, hey, what's a typical NPI process for you? And he said 4 days. Come on, 4 days sounds insane. I've never seen an NPI process take 4 days. I didn't really understand why it was 4 days until I walked on the line. Not going to talk about who they were building for. It's one of the largest electronics companies in the world. These fixtures were pristine. They took many months to build. They were not designed by this manufacturer. They were given fixtures that were designed by absolute experts, and these fixtures were designed for extremely high yield. I mean, this is a complex enough product to where when they find problems on a production line, they don't scrap the product. They rework directly on the line. So it actually does make sense why that, and it's one of the most automated lines I've seen in production yet. But the reason their NPI process is so short is because somebody's front loading that into their design process. The customer basically said, this will never get built at my yield requirements unless I take care of NPI, major parts of the NPI process long before it goes into production. Smaller customers, smaller factories, right? So by the way, if you go to that factory and you say, is NPI a complex, expensive process, they will say, no, it takes 4 days. It's pretty simple. There's really no problem, right? If you give me everything I need, it shouldn't be very expensive. So you go into a factory that's used to dealing with smaller production runs, smaller customers, their answer is going to be very different. That NPI process, Chris, is measured in at least weeks, but in some cases months, right? What's most important is that I never see customers ask enough questions about how that process works. And again, I see a lot of scenarios where people go from, on our platform, they go all the way from prototype to very high volume production. The process is, in some cases, I got to say, baffling. I think a lot of people use criteria that I just don't understand. You ask them, hey, you've been with the supplier before. What happened? We had quality and on-time delivery issues. We're looking for a new supplier. Great. What is your process for finding a new supplier? We're doing a price bake-off. We're going to shoot a quote to 4 different suppliers. We're going to see who's the cheapest, and that is the one we're going to choose. No questions asked about how they build a product, what the NPI process looks like, what is required from the customer in order to make that product successful. There seems to be just a massive disconnect in these two worlds, and there's got to be a better way of doing this, right? I know I threw a lot out there, but that's just my observation, right?
Yeah, and I think you're, one of the things that leads us to, so to think about an effective factory, they're going to put gates if you don't put gates in there, right? They're going to say, hey, look, I need this to work at this stage very well before I move to the next stage, because I don't want to, deploy workers and machines over here, and then come to find out that, I'm getting too low yield there, and now we're adding cost on cost, right? Everybody gets upset and frustrated there. But thinking about that point about, hey, another manufacturer failed to effectively build my product, right? Now I'm coming to you. One of the things we're missing in that conversation a lot of the times is exactly what happened. Why did it fail, right? Is it that they just had low quality and they did a very effective NPI process, but they weren't able to maintain and manage their process? That's usually the rarest outcome. It can happen. We will see that when, hey, this factory has been producing my product for years just fine. Something changed. Now it's getting worse. But if, hey, from the start it did not work well, that may be on the factory, but it may actually be the process itself. So talking about exactly what went wrong, what the process looked like to get there, and then looking at that and saying, okay, now how can we do this differently? That's really important. And I think that brings up another bullet point we have here is maintaining excellent documentation, right? What did you learn in your previous builds? Is all of that being updated, put into information you're maintaining about how to build your product? If we don't have, if we're coming here and if we're talking about a product and it's a complex assembly, it's got multiple sub-assemblies, and what we have are a bunch of Gerber files, bills of materials, and a quickly thrown together document of connect this to that, we're going to have pretty big issues, right? There's going to be a large amount of information necessary about every part in there, about how it's going to fit together, right? Things like torque specs for screws. A lot of times people miss that in their documentation. They say, screw this in there. The last thing you want to do on a volume production line is hand a bunch of people a regular old screwdriver and say, screw this screw in. You're going to get 50 different ways. Half of them are going to crack the PCB, half of them are not going to be screwed down tight enough. That's why we have to have things like torque specs in an NPI process, right? The goal is to come out of there with great documentation and a great process, including any special tools needed to do it effectively. So if we see that a product has failed at another factory and there's none of that information, that's a pretty good indicator for us as to where we need to start. The documentation isn't good enough, and that's the first step in the NPI, is to figure out where all the gaps in the documentation are and to refill those.
And for somebody that runs, because we are the manufacturer for our customers, we own the entire production process, we own the outcome of those products being built. So we have our own engineering teams that deliver products to customers, but ultimately our job is to make sure that every bit required for that job is reflected on our platform and documented. Just saying documentation for the PCB design is not quite enough. And to give you an example, sometimes you have to explicitly specify manufacturing instructions that don't even sound rational. One of the craziest scenarios I've seen was where customer chose a connector where the leads literally didn't reach the PCB close enough where a normal soldering process was ever going to work. And the only way to build it was to really break out of spec and just cake on solder. And they just couldn't choose a different connector. Factories can actually build a product like that. They'll be happy to do it if that's what's required, but you got to let them know, look, we chose a component, it's suboptimal. It's not going to be an easily solderable component. Here's what we need you to do in order to build this successfully. It doesn't work without that level of definition if there's something exotic about that design, right?
Yeah, indeed. So let's go ahead and...
Well, actually, one more question on this. So I think it's easy enough to say that ideally we have in-circuit testing for every design. Ideally, there's a test fixture that exists. That makes sense for projects of certain size. There are projects that always fall right in between where, look, in all honesty, I think a production run where it's less than $100,000, but where ICT might cost $50,000 may or may not be warranted. So, manufacturers will accept jobs without fixtures. So two questions. One is, when you don't have these things in place, what is a reasonable expectation for testing and inspection and quality level? And two, I mean, how do you advise people when these are not optional anymore? Is there a price level? Is there a spend level? Is there a volume level where you just simply have to have in-circuit testing to get it done right?
So in-circuit test is one type of test, and really that's a high volume test, right? There's a lot of costs associated with that. But to roll back, there is no product that goes into a customer hand that doesn't have test, right? Just fundamentally, it's going to be tested somewhere. The question is where is it tested, right? If you're farming out just PCBA work and you're saying, hey, just build these, and build them to IPC standards, et cetera, you're going to have to do that testing, right? Now the question is where is testing most efficient and best cost controlled? It's actually back on the manufacturing line. So while in-circuit tests can be, very useful on, higher volume runs, because there is a lot of fixed costs associated with that, and you have to, of course, have a factory that's made the capital investment in the ICT in line. You can also rely on flying probe. It's got a lower cost. It's slower. It's, I would say, probably more lower volume factories are likely to have a flying probe than a true in-circuit test. But you can also do this with test fixturing. You can build custom functional test fixturing, and it can be very simple, and it doesn't have to be incredibly expensive. But what are the most likely failure modes of something being built? And again, you learn that from your prototyping process, because you're going to run into failures in assembly. What are the most common failure modes, and then how do we test those in the manufacturing process? Because having built that unit, it looks good, everything looks fine, ship it off, right? There's now cost both associated with the shipping, the timing, and then getting it back and reworking it. It's always cheaper in the long run to identify those in the manufacturing process, where they can be rapidly either pulled out of the production or corrected, repaired in process. It's always going to be cheaper to do that. So if you're looking at a fully loaded cost of delivering your product, test is going to be in there somewhere, and it's most cost effectively done at the factory where it's being built.
And I think I know that I said that was the last thing, but I have one more. I would not consider, for true production runs, first articles to be optional. Every time I see people skipping those, there's a price to pay. Rework on thousands of boards is always immensely expensive. First articles should really utilize as much of your production process as possible. And if the factory is struggling to build first articles to your requirements, chances are it's not going to get any better at a higher volume production run.
Yeah, so I want to, since you brought that one up, we need to cleave it in two, right? There are people who try to use first articles to replace an NPI process. Just go build it and send me 5 samples, and then I'll tell you whether or not to continue building. That is not a true first article, right? That is an attempt to skip past an effective NPI process with your manufacturer. By the time you get to production, there should be golden samples of the boards. The first article process should be done on the line by the factory against that golden sample, including whatever test fixturing you have, and that is to test and validate that line configuration, right? So we have to be really, conscientious of that. When someone goes to a factory and says, just go ahead and build this, just send me the first articles and we'll test them. That's not necessarily the most effective route. Yes, you need to do that, but that's really an NPI process, right? Let's work together to validate the manufacturing process, make sure we know it all, and you can be integrated in that as a customer. But once we move into production, all of that should have been figured out by then, and now we're just comparing the line recipe to what was specified.
Okay, I think we're ready to move forward.
Yeah. So So Misha, I want to call out one thing on this slide. There are things here. There's obviously two things. We have covered realistic timelines, but there's a reputable PCBA manufacturer. But there's that word. I like repeatable, right? There is. You brought up this point earlier about switching. Going to getting quotes from different manufacturers, and we see this a lot. People, a lot of times procurement people are rewarded in saving money. They're punished for hitting quality defects and failing to meet on-time delivery, out of stock issues, but they're rewarded far more for saving money than anything else. And this often, this is not everywhere, but this is, I've seen this in a lot of companies. This often drives them to take the wrong behaviors, right? Hey, we had this built successfully at this last manufacturer. They've been building it for a year, but I'd like to save another 10%, and this manufacturer can't give me 10%. So I'm going to go out and do a bunch of quotes. Well, again, you're going to have to go through that NPI process with a new manufacturer. It won't be as expensive as a full-blown one, but there's going to be costs associated with that. There's going to be time, right? And this is where we see things failing a lot, where you had a successful manufacturer and you're really focused on saving money and you're switching manufacturers for that reason. Switching manufacturers is one of the most costly and slow things you can do. So I would generally, recommend people, if you're getting a great result out of your manufacturer, ask them, how they can achieve a cost savings over time, and what they recommend doing there if cost savings is your target, rather than just, hopping out to another CM and doing a new quoting process and picking a cheaper one.
Chris, there are a couple of questions from the audience that I think are important to address. And I think there are at least two that we should pause on now. I think one of them is getting multiple quotes for jobs is critical, but it slows the process down. Is there a way to streamline that without sacrificing quality? First of all, the answer is yes. First of all, there are aggregation tools out there. MacroFab is one of them, where we work with multiple factories. We have a lot of inputs into what factories charge for manufacturing. So when we give you a price quote at MacroFab, for example, it will be synthesized quotes from multiple factories as inputs. But I would challenge a notion that it's crucial, right? Because the thing you're testing for when you're getting multiple quotes is primarily whether that factory has a good enough supply chain team or not. At the end of the day, they may be constricted on number of board houses they use, right? So that might be where some of the cost overruns are coming from. But ultimately, for components, we all buy from the same supply chain. Now, sometimes the manufacturers just aren't big enough to get good enough volume discounts, and sometimes they just don't know how to run their supply chain. That is something that I think a competitive quote can reveal for you. But if you're looking for some manufacturers that are more expensive than others because they're living high off the hog and making too much profit, I can almost guarantee you that's not the case. There are very standard margin levels across the board in this industry. And chances are, if you're seeing major price variability in these quotes, you're not actually measuring whether somebody is making too much profit. You're actually measuring potentially whether they're cutting too many corners. And I wouldn't necessarily rely on that signal for 100% of your questions. Chris, is that the right way to frame it?
Yeah, that's a good way. I would add a little more to that. The question is if on everything, like say you work with 4 contract manufacturers, right? And every build run, you're going to run quotes across those 4 manufacturers. They're going to know after a while they've probably got about a 25% chance of winning it, right? So, how do we make that run faster? Well, part of it is what is their belief that they're even going to get that deal? If you've come to them multiple times with multiple quotes and they haven't won any business from you, right? That is not going to be the highest priority on their list. That's the first thing to understand is they're going to, maybe they're desperate, maybe they need some work, but most of the time they're going to be looking at this going, what is the probability that I'm going to get this deal? Right. And if it's a low probability in their mind, they're not going to put as much effort into sourcing, into getting the best pricing, et cetera. But But I do want to answer the question directly, right? What are the things we can do to speed that process up and improve the quality of our quotes? And I'm not going to say the quality of the production outcomes, because that's not the quote itself that's going to help us there, but the quality of the quote. The handful of things right off the top of the bat. We talked about documentation. Providing a complete set of documentation. If this has been built before, provide them all process information you have, all the documentation you've developed. The second part here is we see this often. A lot of times, the customers will be trying to be coy, right? They know they have registered pricing with multiple manufacturers and they don't tell you, right? They're like, well, hopefully you could figure that out. The reality is a lot of the distribution won't let manufacturers know that unless they say specifically who the registration, what manufacturer it's with.
I don't think it's a lot of the distributors. I think it's all distributors. I think the rules of the engagement are a manufacturer can't just go to distribution and say, tell me about all the registrations. They're not allowed to disclose that information without customer authorization. So it's an impossible thing for a manufacturer to go do.
Right. Some of them can. There are people who will leak that information, et cetera, but that's not a way to rely on it. Give them your LOAs, right? If you have LOAs with manufacturers.
What's an LOA, Chris?
Letter of authorization, right? If you have registered pricing, give them letters of authorization with the quote package saying this is who I have registered pricing with, and you're authorized to access it. All of those things speed up that process and increase the quality of the quote. The other thing, and this could be contentious, if you're learning something about your bill of materials, like availability from one manufacturer or from one contract manufacturer, and you're hearing about alternatives that are having to come up, it might not be bad to offer alternatives to the other ones, right? If they're not picking them up yet, if they're not seeing it, it may be helpful to keep them in there. It depends on what you're measuring, right? Are you measuring their ability to build that product cost effectively, or are you measuring their ability to suss out and produce a really great quote, right? Those can be two totally different things. The right factory, in a lot of cases, for building your product may be the worst at quoting it. They may have the highest quality, but they have no idea how to beat factory X over here, supply chain team, on identifying parts. So go beyond the quote itself. Visit the factories, look at the other types of products they're producing, and make sure that you're sitting somewhere where they actually can be the right partner. And if they need help in the quoting process, help them in the quoting process.
One last thing, because I think you're on the right track making this practical and direct. I think customers should be very transparent with manufacturers about their target pricing. I guarantee you there's no manufacturer out there that wants to produce a quote that's too high. In most cases, and look, you will know, right? When you look at quotes and they're deviating from each other by 30 to 40%, that's not somebody overcharging you. That chances are somebody made wrong assumptions in their quoting process. And sharing your target price with them, and frankly, sometimes is just, if you believe in that supplier and you think they're going to do a really good job, not every decision should be price driven, and they're too high. I would take the 10 most expensive aspects, maybe it's components, maybe it's labor, on that quote, sort it in a descending order, and try to figure out why they're so much higher than everybody else. Usually there's a reason. There's something in their assumptions that they gave to their supply chain that isn't making sense, and that's the reason why they're over on that quote. Let's do one more question, because I think this one is really important. So there's a great question. How do you recommend an engineer explain to sales and business team that they shouldn't push through the NPI process as soon as possible? Here's some color on that, and I'd love to hear Chris's perspective on this as well. The reality of it is the sales and business people think the engineers don't care about timelines, because all they care about is getting it right. So they believe you're there to slow down projects. And in some cases, I got to say, that may not be an unfair assessment on our part. When they deal with supply chain, right, and this is purely based on incentives, supply chain only cares about prices, and they only care about lowest possible cost. So it becomes this, they're watching two teams push and pull against each other. Engineers want a perfect product built the slowest possible way, but most methodologically in the best possible factory in the world. Supply chain team is pushing in a different direction, saying, I found the cheapest one. Why can't we just use this one? Believe it or not, that is not what business people and salespeople want at all. And look, what are their incentives? If they're launching a new product, they certainly want to get to market faster, but I guarantee you churn risk for them is the biggest concern, right? They're what's really expensive, aside from the initial investment in building a product, is the sales effort. And when you acquire a customer, only to lose that customer because of inability to deliver on time, or worse, because of quality problems, that is going to be your biggest argument against skipping the NPI process. The more you sound like you understand their concern about churn and ultimate business outcome, the more likely they are to believe that you're a true business partner and want to work with them. And you don't have to be alone in that regard. They will take third-party opinion as something that's valuable. We as manufacturers are happy to join you in that conversation and talk through, here's what's a reasonable NPI process looks like. Here's how we're going to get to an outcome where you're not going to have embarrassment in front of your customers, executives in a room trying to understand how they could have possibly taken such a wrong turn. I think it's got to be framed the right way, but do understand that they believe by nature you are trying to slow down their projects. Anything to add to that, Chris?
No, I think you've put some pretty good color on that, Misha. So I think that's a sufficient answer.
So, Chris, kick us off here. I know we're going to have a few minutes left, so we have a few more topics to cover. What's most important for us to know at this stage?
From my perspective, right? I want to wrap it up and summarize and put all these things together, right? And we can frame this a couple of ways, right? One is treat your manufacturer as a partner, not as a beauty pageant contestant, right? At a very basic level, you need to pick a good partner and work with them towards success. That includes listening to them on the NPI process, working through. From an engineering perspective, we want to help eliminate production problems as early in the design process as possible. That is the lowest cost. That is the most effective way to do it. And that means, as design engineers thinking about what I'm designing into this product, how I am thinking about it being built, am I working to develop tooling as I design so that we can start answering questions about how we can facilitate manufacturing and testing that product? And then finally, how is my organization supporting a low-cost product, right? Is my sales team, do they understand the importance of quality and the time it takes to get there? Have I put my business costs into the right category, right? Is NRE a capital expense or is it a per unit expense? Similar things like that, right? But thinking about it as a whole organization, how do we deliver that? And what role does each person play, from the product owner to the design engineer to the contract manufacturer and the procurement team? What role do each of those play in driving costs, and how can they think about that earlier on in the process?
Chris, I think one of the results of the poll is quite interesting. The question was, what are the biggest challenges in getting quotes for PCBA manufacturing? And in number one position is difficulty in identifying hidden fees and additional costs. That is directly related to everything we talked about NPI. The NPI process is where you figure out what is truly required in order to build this product at the right quality level. So what may look like a hidden fee is actually a discovery process for what it truly takes. And I would not assume that it's understood what the cost of manufacture is until after NPI is done. It's very difficult to know that off of quoting assumptions, unless there is really good documentation, and maybe it's been manufactured somewhere else, and there is a ton of lessons learned, and maybe test fixtures are already done and pristine. That might be one situation where there really shouldn't be anything hidden or no surprises when you go to production. Right?
Well, let's talk about the number one hidden fee, right? And it's not going to show up in any quote, but it's going to be smeared across the entire quote. The number one hidden fee, and it's not really a hidden fee, it's just this happens this way, is the belief by the contract manufacturer of how much of a mess this project is going to be based in the level of documentation and information they were given about it. So again, you give them very little information. They're like, yeah, I can build this, but man, I'm going to have real low yield for a while. I'm going to have to sink a bunch of engineering time into it. So suddenly my labor just got 20, 30% cheaper. My BOM got more expensive. My BOM got 5% more expensive, right? Et cetera. Because they're looking at this going, what is the probability I'm going to lose money on this, right? I don't have a lot of information about it. So a lot of times, the difference in price can come from the level of information you're providing. And that can go the opposite way as well, right? There are a lot of manufacturers who will give you a low price and then eat you alive with price changes as you get into production. Because, oh, yeah, we made this assumption based on what you told us, and that assumption was not true, right? So now it's going to cost you twice as much for this step. Because here's where we found it. If you've never built the product before, right, go through the NPI, get an understanding, right? Understand that you may be looking at an estimate of the price, but say, hey, look, we're going to work with you through the NPI to do everything in our power to get the cost to the level you've documented here. And that can help them be much more comfortable in giving you a truly accurate price quote versus if they think that, hey, these people have no idea how to make their product and they're going to beat me up later over the pricing. I'm going to go ahead and and they won't let me change the pricing once we learn that. I'm going to go ahead and add margin into this just to cover my potential losses.
By the way, I think there's a number of other answers here. Confusing terminology and unclear pricing structures. One big one is lack of transparency in a quoting process. That's actually one of the biggest reasons why Chris started MacroFab, but one of the things that we aim to change about this industry. But I will echo this frustration. I do think that there is a lot of there is a lot of lack of clarity, and I think a lot of it is just implied over the years. We certainly don't operate this way. In fact, our pricing engines are driven by market inputs, where there's a lot of factories feeding their costs into us. We use AI to generate a lot of our quotes. But I'll tell you, I talked to a VP of sales from a very large manufacturer. They were in the top 5. And she was kind of surprised that we do quotes all the way from prototype to production scale. And I asked her, what was your quoting process when you were at this $25 billion manufacturer? She said, look, I'll be honest with you. All customers are unreasonable. They all have unreasonable price expectations. So they give me a target price, I agree to it, and then I find a way to charge them for extras later on. Look, that does happen, I think, a lot of times with bad suppliers. If you had a bad experience, chances are it was a supplier like that taking advantage of the situation. Now, maybe the demand was unreasonable, but I certainly don't think more hidden costs and just assuming that you got to say yes to unreasonable price and making it up through surprises later is the right way to do it. I would hold all of your manufacturers accountable for not doing that and being very clear about the cost breakdown and really look at the job overall, right? A lot of times these things are quoted in a traditional manufacturing world off of spreadsheets. And the spreadsheets were put together when the company was started by the founder, and nobody knows how the spreadsheet works. So sometimes they're trying to pull something, and sometimes they just don't know.
I'm looking at something interesting here. There's an open poll right now, and it's saying what factors make you more likely to choose one PCBA manufacturer over another. The lowest rated answer right now is experience working with projects similar to yours. I would actually like to say for people thinking about that, that should potentially be a larger factor in your decision making, because what you can do in a lot of cases there is you can leverage other people's investment, right? If they're building products that have similar steps and similar processes to yours, there's a lot of cases they've already learned how those can go wrong. So shouldn't always be a huge part of your thing, but it should be part of your analysis there. And really the analysis is, how much can this factory teach me about building my product successfully? Either it's because they just produce a lot of products like mine every year, or there's a product extremely similar to mine in a way that's really challenging for us, and I can leverage their experience there. So I'm not saying you should rate it higher, but that was definitely one of the things that I think is worth thinking about and talking to your contract manufacturers.
Let's knock out 2 more questions, because I think there are some. The question from Warren, if you know your own BOM cost, what should be a reasonable estimate for PCB assembly cost? Look, Warren, transparently, here, that's a difficult question to answer, but here's where the margin levels are for this industry, right? For low volume jobs, it's about 25 to 30%. That's kind of where it settles. And sometimes it's more if you're primarily working with all U.S. inputs, like U.S.-based PCB fabs, U.S.-based labor, it may be higher. But ultimately, 25 to 30% is the typical margin level for those suppliers. Now, that's a combination of labor, which will usually higher margin, and components. Components are usually about 18 to 20% in markup. So that's a reasonable thing to expect. And honestly, I would make sure that your manufacturer makes money on your job. That is really important. You do not want to be in a situation where they're losing money on your job. It feels like you're getting something, but you're not. They're gonna somehow, something's gonna happen. You might get fired as a customer, or they might cut quarters that you're not aware of. I just don't recommend a situation where they're not making money. Higher volume jobs, they typically settle into about 20 to 25% margin territory. So that's a reasonable perspective for a manufacturer to take. And then when you get into ultra high volume jobs, and we're talking about millions of dollars, those get into kind of teens, right? Anywhere from low teens to high teens, but we're talking about $20 million plus projects, right? So it's important to understand what is the level of your PCBA job. Last one, and I thought it was a really good one. What question should you be asking your suppliers? What should you be doing to choose the right suppliers? I think one of the biggest things that I see not done in this industry are reference checks. There's a lot of quotes floating around. There's a lot of people choosing suppliers based on price alone. There's not enough conversation happening. I would ask your supplier, hey, you're going to have customers similar to me. I want to talk to some, but I don't want to talk to somebody who is 100% happy and only has good things to say. Give me one that had some problems. Maybe had a bumpy experience on the way up, but eventually you got it right. That's the one I want to talk to. Ask him some probing questions for what happened. How did they handle it? This doesn't happen enough. I think, and frankly, if they don't have customers that are willing to talk to you, I'd be worried. But I'm always startled by how few people ask for reference checks. That should happen, right? And it doesn't.
Okay, so Misha, I think we've talked long enough. We only got 2 minutes left. I know Dale's got a few things to say, so
Dale,
you're on mute. You're still muted.
So to turn both of them. Thank you guys for your presentation. There's a lot of people in this industry that have a lot of great ideas, but they got to create products, but they don't have that expertise of getting printed circuit boards built. And so, but that becomes a part of the product. So I think you provided a lot of good things for them to think about. So thanks for your time today, guys.
Thank you. This was a lot of fun. Thank you.
Yeah. Everyone, a PDF copy of today's presentation from MacroFab is now available for download in that upper right-hand corner in the handout section. So you might want to grab that now. And then in just a moment, you'll be redirected to MacroFab's website, where you can access a special offer for 50% off your PCB assembly order. Gentlemen, thanks again for that great presentation and the discussion during the Q&A.
Thank you, Dale. Thanks for having us today.
And thanks to your audience for your participation. You'll be able to view this session on demand using the same link you've used to view the webinar today. So thanks to everyone for your time. We look forward to seeing you at another live session again sometime soon.